Hello, this is Jim McKeith, lead developer evangelist from Barcadero Technologies, and I wanted to make a quick video talking about Hour of Code. The idea behind Hour of Code is every student should take an hour, or I would say more, to learn a little bit about how to program computers. Now, even if you're not planning to go into software development, it's still a good idea to know about computers. And this is a great opportunity, a great program. You can see here all over the world we see students are taking advantage of this program or reporting that they've taken an hour to learn to code. So even, like I said, even if you're not going to be a computer programmer, it's still useful because computers are such an important part of our life. And by learning about how computers work, learning how to program computers, we get a better understanding of what they're capable of, how we can use them better in our lives, and what sort of problems we can expect computers to solve. So go to here at hourofcode.com. They have lots of resources on here you can take advantage of, or there's lots of other resources around the web. I'm going to show you some stuff I'm excited about, and I encourage you to, even if you're not a student anymore, take some time, learn to code, or share coding with somebody you know, and help spread the knowledge. So this is a new site I just recently discovered, Code in Game. Now, I'm not sure if I'm pronouncing it right. It's Coding Game or Code in Game or something along those lines, but it's CODINGAME.com. So this is one of the better sites I've seen for what it does. It lets you solve simple little problems in a game-like setting using your choice of programming languages. It has a huge selection of programming languages. Let's see if I can remember where the programming languages is at. Let's see, I'll go into this one here. So this one is, you're going to try and get Thor to reach. Here we go. So languages. There's a lot of languages you can choose from. Quite a few. So I've selected Pascal here. And it says Pascal, but it's actually Object Pascal, although you're writing procedural code. But it's, if you look at this here, I'll go back to the code window. We see right here is a T-string list. So T-string list was created with Delphi. I believe Delphi 1 probably had the first T-string list. It's a list of strings. This is not actually based on Delphi, though. It's based on Free Pascal. It's using Free Pascal. Free Pascal, in turn, was based on Delphi. So that's cool. This means if you know Pascal or you want to learn Pascal, this is a great resource with Delphi. You're not going to be able to use some of the latest features of Delphi, unfortunately, because it's based on Free Pascal, but it's enough that you can get going. So now if you don't know Delphi or Pascal yet, there's a free book here, the Essential Pascal by Marco Cantu. You can go here to marcocantu.com/epascal and download it for free. There's right there, Essential Pascal. You can also, I believe he has print versions available. If you want to get, this book's from quite a while ago. I don't remember the date on it. Let's see. 2004 is the latest update, but it was written in 2000. If you want a more recent book, though, you can check out this one here. This is his Object Pascal handbook. This one was just recently written here in 2015, so just this year. It's not available as a free download, but you can buy it on Amazon or CreateSpace. Although, if you get a free trial of Rad Studio 10 Seattle, which is the latest version of Delphi, then you can get a free copy of the Object Pascal handbook by downloading it here. So I'll have all these links available on my webpage, but let's go ahead and take a look at the Coding Game. So I think this is a brilliant way to introduce people to programming. Now, it kind of assumes you have some programming knowledge. That's why I recommend you take a look at this book here on Essential Pascal so you can answer some of those questions you need to know about how to solve these problems. But let me show you how this works here. So we have this game window here where this is where what we're going to control, what we're going to interact with. And what we're going to do is we're going to solve a specific problem here. We're not dealing with graphics. We're not dealing with anything like that. We're dealing with how to solve a specific problem. So in this case, what we need to do is we must program must allow Thor to reach the light of power. So if I run this here, we'll just go ahead and run this one. Now I've already ran this once. He just goes up and off the edge. Let me change this here to down. I've already solved this one, but I took my code out and tried to go back to what it was originally set to. So see, he just moves off the bottom of the screen because every time this loop goes through, he just moves south. Okay, but our objective is to move him over here to get this light of power. Now, if you go through here, this explains the variables you have, the input you got for your program. It explains your output options and what the winning conditions, losing conditions. It talks about that you need to have a loop. It has some suggested variable names and what you're going to do, and shows some examples of what this goes through. So this explains a lot. Now, one note is this is not code here. This is pseudocode. This is explaining what you're going to do and kind of halfway between straight up English language and programming language, but you can't copy and paste this over here and make it do what you want it to do. All right, you have to kind of use your brain to move between the problem description, the pseudocode here, and the actual code. But this, I just love this. It's got so much information here for you. Like, explains what's the mins and maxes here. What are the constraints? Response time for game round is less than 100 milliseconds. Beautiful, beautiful stuff here. Everything else, every other one I've seen like this doesn't give you enough information to really get creative in how you're going to solve the problem. And then I have down here these test cases that you run through. Now, in real programming, you're going to have test cases where you need to solve a problem, and then you're going to use a test case, unit testing, for example, to prove that you've solved that problem correctly. So this right here is a great, what's the word I'm looking for? A great analogy, or not analogy, but model of what this would be like in actual programming. But it's cool because it's Thor, and it's kind of a game-looking thing. So now in here, you're going to usually have some sort of code like this. Like I said, it's procedural codes that just says program, answer, and then we have a procedure here. This is parse. You don't usually have to mess with this stuff here. And then you have this where it sets up your initial things here, and you're going to have some sort of game loop. So you're going to come down here and find the game loop. And in here, it's parsing out the inputs so that you have your remaining turns, so you can keep track of that. And all you have to do is change what the right line is here, right here, right line. Right now, it's just right lining S for south. There's the possible outputs. And so Thor moves south every time the loop goes through. So if you remember, the loop is less than 100 milliseconds is the response time. So he's just going to keep going south. Okay, so we're going to change this. So Thor starts right here, and when we get here to the lightning bolt. So if I change this to just have Thor move to the east, right? So the east is that direction. And now we run this test. We see Thor made it to the light of power. So we've actually passed test 1. So this is something that comes up oftentimes in programming, is you're like, oh, I can solve this problem, boom, 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 and you're done. And then you go to run the second test. And you're like, oh, it doesn't work in that scenario. So while this is great, this is very simple, we only get one green light and then we get one red light. So we have to come up with a way that's going to solve both of these. And now you can maybe come up with something that says, oh, if it's above me, then we'll go up. If it's to the right of me, we'll go right. But then you have these here, we have different angles and stuff like that. So it's a little more complicated to solve than what you could do. So basically what I'm trying to get at is, instead of just trying to solve the specific scenarios we might get, instead we need to say, what's a way we can create an algorithm, create a code that's going to be able to solve problems that we would receive in this group. Okay, so we could write one that says, okay, here's the 4 scenarios, and we can figure out which of these 4 scenarios we're in and go there. But then as soon as we get a 5th scenario, that would break down. So instead, we're going to have it figure out what direction it should go in, and then move in the right direction. Now, what I'm going to do here is I'm going to add in a couple more variables. So we're going to have Thor X and Thor Y, and we can use this to keep track of where Thor is at, because we don't get that information back in our inputs. All we get is remaining turns. We do get where Thor starts, initial Thor X, initial Thor Y, and we have where the light is at, which is light X and light Y. Now we only get that at the beginning. We don't get that inside the loop, so we have to keep track of where Thor is at manually. And then I'm also had some variables here for move X and move Y. And this is going to be used for creating the way Thor moves. So we're going to look at where Thor's at, where Thor needs to go, and then we're going to construct a movement for him. Okay? So down here, after we get the initial Thor x and the initial Thor y, I want to initialize my Thor x and Thor y with those values. Thor x equals, and Thor y equals. Okay, so here's the variables we declared, and now we've initialized these with that value there. I guess I could have just used initial x, initial y, and changed those, but I felt like it made more sense to introduce new variables to do that, and that way I always have where he started from. Although, honestly, once he started, I don't need to keep track of that anymore, so maybe later I can optimize this and remove those second variable declarations. And we're also going to initialize, actually let's do that in here. So here's our loop, and so Thor's going to start wherever he starts, and then each loop he's going to move. We need to have him move. That's one thing that's important here, is that he has to move once each loop. We have to have one right len each loop, and only one right len each loop. And I've looked at a couple of different scenarios, and they all seem to behave that way. There may be other ones that don't behave that way, but if you try and right len north and then east, for example, if you want to go northeast as two separate right lens, it won't work. It'll just accept the first one and then ignore the second one, or it creates odd behavior. So you want to only have one right len, a single line providing the move, and then it could be these combination of values. So that's why we're going to use these strings of move x and move y. We're going to construct that. So it could be, we're going to see if he needs to go horizontally and see if he needs to go vertically, and if he goes both, we can combine those together. So let's initialize move x to empty string, and move y to an empty string. And now we're ready to deal with this. We'll go ahead and do it right here. Oh, I gotta remember to comment this one out. I've done that before where I don't comment it out and he does this weird behavior. I'm like, what's going on? It's because I left the default behavior in there. So remember to comment that out. So first we're gonna look to see if Thor horizontally on the x-axis, if he needs to go that way. So we say if Thor x is less than light x, then begin. So this is an if statement, if you're not familiar with if statements. And this is a block of code, begin, end. And we're going to say, so if Thor x is less than light y, so if Thor is currently less than light x, sorry, not light y, then we're going to say we're going to move. I'd like to keep my case. So Pascal's not case sensitive typically, but I like to keep my case consistent. And then if I keep trying to capitalize move x, I should have capitalized to begin with in the declaration. But anyway, we're going to say move x is equal to east. Okay, so if Thor is less than light x, so if he's right here, so he's less than the light, then we need to move east. Right, east is that way. So remember, this is 0. See, I love this. It's got all the information you need right here. And move east. But we also want to update his location based on that movement. So we're going to say increase inc Thor x. And that's going to increase the value of where he's at, because we know he's going to move to the east. Now, if he's not to the left of it, then we assume maybe he's to the right of it. So we're going to say else if Thor x is greater than light x, then. And again, so we're doing an if then else. So if then else, another if, then we're going to say move x equals w. Okay, so we're going to go to if he's to the right of it, then we're going to go to the left, and we're going to decrease Thor x. Okay, now if he's neither to the left nor to the right, that means he's straight above it. And we don't want to move him to the left or the right, because then he'd just kind of zigzag down. I guess you could do that, but I don't want to do that. I want to be efficient in his movements here. So I'm going to say else. I guess else nothing. So my point was, if I took this line off here, this if statement here, out, then Thor would zigzag down. Actually, let's go ahead and leave that like that. And then let's do this one here. And then I'll show you what that did, and then we'll change it. If, actually, let me just paste this in here. I did this once before. And then you don't have to see me write it again. But it's the same basic logic of checking except on the y-axis. Okay, oops. Good. And we'll do the same thing here. Okay, so now let's test. Oh, actually, we need to do the right len now. So the right len, we're going to concatenate move y and move x. Right len is move y plus move x. Okay, so let's do straight line. So see how he's kind of doing that wiggly thing? We solved the problem, and we'll solve the same problem here. So he's doing the back and forth. But if we do this here and we say, okay, if he's already lined up, then we're not going to set an x or a y. Okay, so that's what this does here by having that second if check there. So now I do straight line. So he's going to go in a straight line. Perfect. And up. Same thing in a straight line. And then here's easy angle. So there he's at an angle that way. Now see, in this one, he goes down at an angle and then adjusts. So he went down until he was lined up on the horizontal, on the x, and then the x went to nothing. And then optimal angle, which it seems like the opposite of the other one, but anyway, I'm not sure what the difference is. So there we go. We've passed all 4 tests. I love this. It's very cool, and you can actually step through the frames. There's output. There's debugging output information here. See? So as I scroll through this, you can see him passing through the frames. See what the output was. His energy is his number of moves left, Thor's position, light's position, etc. You can output debug strings here. So I can actually do this. Actually, we'll do that. We'll go here, add. Actually, I won't cut that. I'll just paste this here, and we'll say move y, move x. Okay, so we can actually output what he's doing. So here's our error output. That's our debug output, and then this is the output that we wrote out here. So there's a right len, there's a right len error, so we can see both those. So we could have lots of extra information available in the debug output. So for example, you could say, okay, he's going to move east, and on else we could say he's already lined up, stuff like that. So we'll do that here. Else, oops, wrong button. Else, I'll go ahead and put that there. The line breaks aren't required, but they do make it, in my opinion, easier to read. Oops, I got my fingers on the wrong keys. Lined up. And let's go down here. Lined up on Y. Alright, so let's comment that out. And run the test case again. We'll do the easy angle. So see, as soon as he's lined up on Y, we see that it started outputting that lined up on Y. Anyway, this is settings. I can come in here. I can change the speed he's running at. I have him running at 5x, and I have the graphics in high definition. But very cool. You can run it full screen. And then when you're all done, when you think you've passed all the tests, and actually there's a little chat window down here that's going. I actually should have closed that. I'm not sure what was popping up in that chat window. But you can also run all 4 tests at once here. When you're all done, when you think you got it, you hit submit. And it's going to validate your program and compute your score. And the score is based on if you've solved all the tests. Now, I don't know if it's only solving using those 4 tests I gave it. I think it's actually using those 4 tests we saw before. I think it's actually using a possibility of a 5th test, if you will, or more tests, different scenarios beyond that what we solved. So like I said, we could come up with a solution that solved only those specific ones there. Okay, actually, you know what? Here I see right here. Here's the 4 tests it solved, or it gave me to solve. So it only tests me on those tests. But in theory, and maybe some of the more advanced ones do, it could give you a 5th one that you didn't know about. And so that way, if you only program it and say, oh, if I'm in the upper right-hand corner, I got to go to the lower left. If I'm to the left, I go to the right, etc. So you always want to make sure, I think, that you want to make sure you're writing it in the way it's going to solve the most problems possible, but make sure you test it against those tests. That's kind of my philosophy. Now, again, One problem with programming is sometimes we over-engineer things and we try and solve too many problems. Don't do that. Anyway, this was Code in Game. Awesome, awesome site. I recommend it. Come out here, check it out. Choose your favorite language. If you choose Pascal, which I would suggest you do, here's some great resources. You can get a Cisco Essential Pascal. It's available in print or free download, or you can get the Object Pascal Handbook by downloading and activating your free trial of Rad Studio 10 Seattle, and then you can download the Object Pascal Handbook by Marco Cantu. This one goes into much more depth than the Essential Pascal does, but it starts out in the same place. It starts out with information on the basics of Pascal, variables, loops, everything you need to know along those lines. And you're good to go. So, great opportunity. Like I said, if you already know how to program, share this with somebody you know who doesn't. Okay, let's share the knowledge, spread the word, as it were, and introduce more people to programming and the potential that it can have to make their life better. Thanks a lot.